Let's learn about histograms. A histogram looks just like a bar plot. So we have an x-axis, sorry, that's our y-axis, here's our x-axis. And on this side, on the y-axis, we have frequencies. Let's say 5, 10, 15, and 20. And on the bottom here, before we had the outcomes of a specific limited number of potential outcomes. We were talking before about grades, A, B, C, D, and F, and that's in our data set when we have a lot of repeats. If we don't have a lot of repeats, say for example, instead of grades, we were measuring the heights of students to the nearest inch, and it would be very unlikely that we would have a lot of students that were exactly the same height. So instead, we would do something like this. We would start here at 4 feet and go up to 4.5, and then to 5, 5.5, 6, 6.5, and 7. And instead of then counting up specifically how many people were exactly that height, were exactly 4 feet, we're now counting a range here. How many people were between 4 feet tall and 4.5 feet tall? So it's not a specific outcome, but a range of outcomes. And when you do this, it's very important that the range for each of these be the same, right? These are each 6 inches wide. They have to be the same. But in that case, in our class, we might have, let's say, 10 students that were between the heights of 4 and 4.5, 12 who were between 4.5 and 5. We have some tall students here, or between 5 and 5.5, we have 20. Between 5.5 and 6, we're at 18. We don't have as many people that are taller than 6 feet, but let's say we have 4-ish that are between 6 and 6.5, and we have 1 student that is taller than 6.5 inches, okay? So that would be a histogram, because we have used bins instead of using specific outcomes. So for this to happen, or it works much better on complicated data sets, on larger data sets, interval ratio data, but it can work on ordinal data. We could have, instead of these being numbers, we could have everyone whose last name starts with A, between A and D, and then what would that be? How many was that? 4? So that would get us up here to G, right? So we could have letters that move across the bottom, but they do at least have to be ordinal. All right, let's talk about how to make a histogram in R. So to do this, I'm going to open up one of the sample data sets that comes with R. So the data command here just tells R that you're opening up a example data set that comes installed with R. So to familiarize ourselves a little bit with this data set, let's look at its dimensions and the names of its variables. Let's also take a look at the first few values so that we get a feel for that. So I will highlight those all and send them over to our console. And so we have 272 data observations on 2 different variables. Those variables are called eruptions and weighting. And these are both measured in minutes. This is the length of the eruption and the time you had to wait for that eruption to happen on Old Faithful Geyser in Yellowstone National Park. So let's make a histogram of the eruption data, the amount of time it takes the geyser eruption to occur. So I'm going to call this duration, and I'm going to extract that, from the faithful data set. It was called eruptions. So all I've done in this command is said here is a data set called faithful, inside of which is a variable called eruptions. Copy that variable and call it duration. Okay, so I've just made it a little bit simpler. To create the histogram, all I have to do is type hist duration, and it will automatically do all the work for us and create this histogram of duration. So this is in minutes, remember, so it has binned these data in half-minute increments, so in 30-second increments, right? So here's a minute and a half up to 2 minutes. Here's 2 minutes to 2.5 minutes.
2.5 minutes up to 3, and then all the way up to 5.5 minutes. So we have about 55-ish eruptions that last between a minute and a minute and a half. Okay, so it took care of that, creating the bins and doing all of that for us. Now, I would like it in units of 15 seconds instead of 30. I think there's more information here. So I'm going to set the breaks equal to the sequence of numbers that begins at 1.5, ends at 5.5, but increments by 0.25. So let me just send this little bit over here so that you can see what that has done. It starts at 1.5, ends at 5.5, and increases by 0.25. 0.25 minutes, of course, is 15 seconds. So now it's going to count the number of eruptions that lasted longer than a minute and a half, but less than a minute and a quarter. Then a minute, or 3/4, sorry, 45 seconds. Then it's going to count how many eruptions lasted 1 minute, 45 seconds up to 2 minutes, and then 2 minutes and 15 seconds, and so on until we get to our 5.5 minutes. And when we draw this graph, this histogram, I think it shows the information a little bit better. I think a little more detail was good there. And then just because I can, I'm going to set color equal to red and border equal to white. Just because we need a little color in there. But that is how to make a histogram of data.